right, so back at it here with our translations notes, video 2 here. So let's use this example. So it says, in learning a new dance, Kyle moves from position A to B and then to C. What single transformation describes Kyle's move from position A to position C? So let's break it down into 2 steps and then we'll go 1 step. So how do we get from A to B? Well, it looks like we have to go to the right 2 and up 2. So our first translation would be to the right 2 and up 2, and that would transform A to B. Now, what about the second set of translations? Well, to get from B to C, we have to go right 1 and down 1. So our translation here would be right 1, down 1, and that would get B to C. So now how are we going to combine that into one translation? Well, first of all, let's write the composition of translations here. So in a parenthesis, I'm going to put the second translation comes first, right? Because you work right to left, so it's backwards. So this one, the 1, -1 goes, or is listed first. We compose that with this translation of 2, 2. Right to left, you would go this way. And that would take A and map it onto C. Okay? So what does that mean? That should be an open circle. It's just bugging me, sorry. This should be an open circle. Make it open. There you go. So what does that mean? Well, to combine these 2 translation rules, we would take this 2 and we would add 1 to it. We would take the y2 and we're going to subtract 1 from it. And again, this would be A to get to C. So 2 plus 1 is 3. 2 minus 1 is 1. And that would be your single translation rule to get from A directly to C. And if you check it on here, I'll use purple. From A, if you went to the right 3 and up 1, you would get from A to C. Okay. And again, I think as we go through the sections, you're going to compose more than just translations. You might do a translation reflection, a reflection rotation. So as we get further along, more fun to come. Okay, next. How is a composition of reflections across parallel lines related to a translation? Here we go. All right, so we're going to take a look at this problem here. So A, B, C. This is our original figure. We're going to first reflect it across the y-axis to get A prime, B prime, C prime. Again, if I were to look here from A to A prime, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we use the y-axis as that middle reflection line to get from A, B, C to A prime, B prime, C prime. So that again would be listed second. Reflect over, and the y-axis is the line x equals 0. This is the y-axis, x equals 0. Okay, so then once you have A prime, B prime, C prime, to get to A double prime, B double prime, C double prime, you would reflect across this line x equals 4. It's called x equals 4 because it goes to the x-axis at 4. And again, it's 1, 2, so you go 1, 2. That would be the second reflection, so we list it first. In this composition, again, open circle. This composition would take triangle ABC and make triangle A double prime, B double prime, C double prime. So then the question is, what would the overall translation be? Well, let's go from the first figure to the last figure. Let's look at B. Notice that it did not go up or down at all, but it did slide 1, 2, 3, 4, 5, 6, 7, 8. It went 8 to the right. So a translation rule to get from triangle ABC to triangle A prime B, or A double prime, B double prime, C double prime would be you go 8 to the right and 0 up or down. And that again would map triangle ABC onto triangle A double prime, B double prime, C double prime. So this would be your rule. So then the question is, well, how does that 8 compare to these parallel lines? Well, look here. Line 1, x equals 0. Line 2, x equals 4. that distance between those lines is a distance of 4. So the distance between the parallel lines is 4. The translation distance is 2 times 4, which is 8. And this is the idea, right? So if you're going to reflect a figure over two parallel lines, then it's going to translate or move left or right, depending on which way the lines are. So these were vertical, so left or right, double the distance between the two lines. Okay, so again, that's a composition of parallel lines to make a translation. Now let's go ahead and open up this Explore tool and let's take a look here. It's going to make me log into Solvus real fast. Sorry about that. Okay, there you go. Let me try again. It's loading. It's loading. Oh, yeah. So again, if I open this up, now look. Okay, it says I can explore by moving this line. So let's say I want to move this line to x equals, let's go 2. So now the distance between your y-axis and x equals 2 is a distance of 2. Look how far it is from b to b prime. 1, 2, 3, 4, double, right? Now what if I move it to the other side? Well, you see I lose it because now it's going to go to the left, right? Because the first line, again, it's two ways, so it'd be 4 to the left, but you know we're going across and then back across. So be aware of the direction of which your lines are reflecting. There we go. Okay, so cool little thing to play around with there. All right, so back in the notes here, let's take a look at the general idea behind this. Okay, so again, if we are translation, if we're reflecting across two parallel lines, then the composition of that is a translation. And again, the idea is that you are going a distance that is twice the distance between the parallel lines. So in this picture, again, A to A double prime, B to B double prime, C to C double prime is 2 times this distance right here. And again, this is a composition of those reflections. So again, the translation is 2 times the distance, and that distance is right here. All right, so this next slide is going to kind of blow our minds, but we'll do it. All right, this is going to be the proof of this idea. Okay, so we're going to kind of talk through this. So again, it says given a translation T with TC, translation of C going to C double prime, prove that there exist parallel lines M and N such that T, the translation, is a composition of those reflections. Okay, so here's what I'm going to do. Over here, I'm going to draw a line. First off, I'm going to put this a midpoint here. We're going to call that C double prime, or I'm sorry, C prime. Okay, and I'm going to draw a line splitting C and C prime. We'll call that M. I'm going to draw a line splitting C prime and C double prime. We're going to call that N. So again, my goal is that these lines are going right in between C and C prime, and C double prime. Okay. Now the distance between M and N is going to be that distance of D. Okay. So we have 2 parts to this. All right. So part 1, as I've set up, we're going to let C prime be the midpoint. Is the midpoint of C double prime, that segment. Okay. So if we take C and reflect it across line M, and then take C prime and reflect it across line N, we're going to get C double prime. So this will be a composition of these reflections, again, right to left. So if you think of, we're going to reflect across line M first, and then line N second, that will take C and make it C double prime. Now, if C prime is the midpoint, right, then that means that we are going half of D to M, and then half of D to C prime. And then from C to C double prime, again reflecting, we're going half the way of D to N, and then half the way to C double prime. So what means is that between C and C prime, that's a distance of D, and between C prime and C double prime, that's a distance of D. So you can see that the distance from C to C double prime is D plus D, which is 2D. So that is the first one. If your C is right, if your C prime, your point of reflection, is right smack dab in the middle. All right. Now I'm going to change colors and do part 2 of this. So I'm sorry, so that was part 1. Sorry about that. So let's do part 2 of this. So now, well, let's pick a random point. Pick a random point B. Let's pick a random point B. And let's put it right here. A little bit closer to that line. There's our point B. So we're still going to do our reflection. We're going to go across M first and then N. So reflection of N composed with a reflection of M of B. So if I reflect B across M, it's going to go right about here. That would be B prime. And then if B prime is reflected across N, it would land about here. That'd be B double prime. Okay? So that's still going to give us B double prime. So now let's talk about how far are they going. Well, let's call the distance from B to this line, let's call this X. So this distance here is X. So then the distance from here to here would also be X. Okay? Well, the distance between these two lines is still D. So if this part is X, then this part would be D minus X. And following your reflection rules, if this is D minus X, then this must be D minus X. So how far is it from B to B double prime? Well, let's add it up. From B to B double prime is X plus D minus X plus D minus X. These X's cancel with those X's. D plus D is 2D. And there we go. We proved this theorem again for some random point. Okay? So again, this is a lot of background knowledge. The textbook thinks it's important to show you guys this stuff, so I'm going to. Hopefully, when you do the problems, this just helps deepen the understanding of why a composition of reflections across parallel lines represents a translation that is 2 times the distance between the lines. All right, thanks for watching, and good luck on your practice.